Well, just tested this out. Looks pretty good. Gonna get started. Where's my freaking window? I haven't journaled today. I need to journal today. Put that over there. Put this over there. Is that it? Yeah, that's it. What is this? Archives episode 2. I knew that. I look really tired. I don't know why I look so tired, but apple. Gotta eat. Wow. Well, energy in a can. I haven't had fruit in so long. I would do energy. Pomegranate blast. Pomegranate blue burst. I'm so tired. I'm exhausted. Like, I'm actually tired. My shit's kind of buffering. What's going on? 21 CPU usage. 60 FPS. It's fine. Where did I leave off? Okay, yeah, so yesterday I set up, at Jupyter Notebooks, setting up problems, explanations, testing. Cool. So what else are we doing today? We're doing the next problem. I'm actually kind of wasting some time with the Jupyter Notebook thing because I already had these problems solved. But the point is just, as I said in the last episode, the point is just to have a place where I can run actual code and like study this away from the course that I'm following, because this course is gonna go away. I sound so slow. The course is gonna go away end of January, so I'm trying to get through it ASAP so that I can pull the knowledge, so I can suck the knowledge from this course while I still have a chance. Okay, so left off with the last tour. Now we're at smallest library with greater sum. Cool. So I think the pattern now is to leave this window open, and we're gonna just add everything via this. Throw down a markdown. I'm putting in this is gonna be, what's this easy problem, right? What is this? This is smallest. Cool. What's my format? I have a problem statement, the problem, explanation. Okay. I brought my whiteboard with me, so I get to write on that. I am not in the mood today. At all. Alright. Let's take a look. So I don't think, well, I have a solution from the last time I did this. That can't be right, but okay. So somewhere in my notes, I wrote, okay, so let's talk about my previous work on this problem. So I think when I last did this, I just erased all the evidence. That's terrible. But basically, last time I did this, I basically was calculating a solution n times. I was looping through this list, and for every integer, I was basically adding something to the n or the I number, and I was using a while loop to basically calculate a sum that was greater than or equal to s from the ith number. So I'd start with 3, I'd then add 4, that's 7, add 1, that's 8. I would then take that subarray, get its length, which is 3, and then I would go at 4 and do 4 plus 1 plus 1 plus 6, right? Get that length. Oh, that's 4. So that's not really sliding window. That's more like that's basically a nested loop. So that was an n. I won't say n squared, but well, actually, worst case n squared. Because assuming that, well, really it's probably n log n because, well, is it log? Yeah, log. I started at 3, I started at the 0 index, looped that 5 times, started at 4, looped that 4 times, 3 times, 2 times, 1 time. So got closer and closer to 0. Basically, it's or closer to 1. Basically, log of n. But anyway, old solution, bad solution. New solution is we should be adding to the sum. While we have a sum that is greater than s, we need to update our min, subtract the start, and then increment the start pointer. But that way we're actually pointing to a number that can be tested. So let's get some code down here. Smallest, what is it, subarray? Takes in an s, which is what? I'll type it because I'm in my personal development, but it's going to be a list of, is that good syntax? I think it is. Cool. So we're going to return some number, okay? We want to define our test before we run this code at all. So they gave us some testing output. They gave us 3 examples. Now, I think last time I did this wrong, but I'm gonna define before. I'll define some tests here because I hate the other format. It's kind of annoying. My formatter does not run here. It's kind of annoying, but we'll say def test. I'll just copy this. It's gonna take in, I think, the same thing, except one more thing. It's expected, which will be an int. I can type all that in. I would just assert that. Assert what? Assert that smallest subarray sum of s and I can well. Equals expected. All right. So this is a setup for our test basically, and this is what we're going to use to run our testing framework. We're using a testing framework called IPyTest, which is testing for. I'm exhausted. I really do not feel like doing this, but I like recording. Recording's fun. That's why people stream. We have to run function. So basically, the idea is to run failing tests all the way through. This is kind of jumpy. Is it because of my, what's it called? Is it because of my OBS? So ipytest.run. It skipped one because there were no tests. Can I add a more verbose output? I'm looking for a more verbose output, but let's say ipytest verbose. Can I get verbose more? God, I sound so tired. No, I am looking for ipytest, not pytest. Can it? Hello? How do I add commands to... Huh. I'm trying to figure out how to run a more... Just args, module name, plugin, run in thread. For run, okay. So there's not really more verbose options. Oh. I can pass args to pytest. So if I run pytest with a verbose output, I can do the same thing here. So let's do, yeah, here we go. So I can pass in like no header. Well, it's keyword arg, so I'm not sure how to pass a keyword arg that's really a command line arg. Exhaustive. I mean, if it fails, I'll know why it failed, right? Anyway, it's not super important. What is all this pytest stuff that I was looking at last night? And pretty much close, I think, all of this stuff that it's running. Can save freaking RAM. My stuff is, let's see what my activity looks like. CPU, memory. Energy. It's for real. OBS taking up mad energy. OBS recording takes up a lot. Spotify's okay. LifeAd is kind of okay. Yeah, I used to use LifeAd as a tracker of like daily work and stuff like that, but it just gets harder and harder to use it because I don't really have a reason to keep it open. I'm gonna quit it completely to save resources, but mostly 60. Cool. Hopefully this saves my Jupyter notebook from crumbling like this. Alright. Let's define some tests. So we're gonna have our what? We're gonna have our, what is it? Our S, our array, and then our, looks like expected will come in later. That's our format. Then our tuples need to match that. So our S in this case is 7. Our array looks like this. 2, 1, 5, 2, 3, 2. And then our expected output is 2. The idea is that we're going to return some value with this, and the point is to run a failing test. So we're going to first of all return this, just return out from this. I'm going to run that cell. I'm going to run this cell. I'm going to run this cell. It failed. Why did it fail? Well, if you look at the code, we're none equal to return. Okay, so to fix that is to edit 2. Great, return that, run that. What happens there? Oh, look, it passed. Okay. The only way to make your code smarter is to make a smarter test. So once you add another one, it should fail again. I mean, you could just test for 2, but that's not a valuable test suite, if that makes sense. So S is still 7. They're the same input from last time. So 2, 1, 5. Actually, no, it's 8 now. And the output is expected to be 1. Run that cell. Run this cell. It failed. Cool. Why did it fail? Well, look, our function returned 2. Look, return 1. Okay, I'm gonna be stupid for a second and do that. Oh, look, return 1. Okay, so you have to actually write some code. What do we need to write? Well, we need to come up with a solution. So how do we? So let's think about this, right? That's why I have my whiteboard with me. Barrel of apples. So tart. Kind of nuts. Whatever. So our sliding window format, usually pretty simple. There's a start for the window at 0. I wish I had like one of those on-screen pen things, but I don't have the resources to even run that. And this is not for viewing purposes, so if I'm speaking really fast, which I know I am, don't worry about it. Not a big deal. Oh, I can label these tests, right? I'll start doing that in a second. Okay. So you run the one test, we can label it like this. But that's a weird way to run a test, but that's also another way to run it. Kind of cool. I like it. I might use it at work. All right, so there's start, 0. What else? Well, let's run through. I'm trying to write code. Our format is the same, but we're going to try and solve it properly. So we have our problem, no clarifying questions. I didn't write that here because it's my README. Duh. It's in the freaking README. I remember it. So restate, ask questions, test and edge cases, come up with a solution. So we have 2 test cases so far. Let's try and figure out how we get to those results. So the idea is to find the length of the smallest subarray that when you sum all the values together, it's greater than or equal to 8, or S, which in this case is actually 7. So the point is that we have this array of numbers, 2, 1, 5, 2, 3, 2. And we want S to be 7. And we want to find the smallest subarray that is greater than or equal to 7 when summed together. So let's take a look. Since we kind of know the pattern with these problems, the nuance of trying to come up with a solution kind of goes away. And the point is just to understand the pattern itself and when to recognize when it makes sense to do something like this. So we know it's sliding window. So we're going to implement some sort of window tracking algorithm. So it's going to be starting at 0. It's going to be, there's going to be sort of an end tracker as we're looping through the list. The conditions for when we try to adjust our window, if we're going to do this intelligently, the conditions would be to shrink our window when we hit 8, right? So if I'm looping through this list and I start with 2, I say I just add. So I start with 2 to my sum. Okay, let's say uh, min length as another variable, starting at I think infinity for that sake. All right, so I'll start with 2. Then we'll say 2, and that's our condition, our if statement, our while loop, right? Our catch here is going to be like while our sum is greater than or equal to s, continue to shrink our window. So continue to add to the window. So we'll keep on running sum somewhere. Cur sum plus equals, we'll just say end, which will point to a variable in the array. So what I have so far, we have a starting number, a starting pointer. We have our minimum length being set to infinity. So anything less than infinity as it gets lower, it'll be updated, right? We have our list. We're looping through the list. We have an end variable pointing to the end point of our list. Currently, our start is equal to our end, 0, 0. We're going to add to some kind of sum tracker. We're going to add an end. We're going to add our end, which is 2 currently, starting at 2. So we have 2, while our sum is greater than or equal to s, which is currently 7. 2 is not greater than or equal to 7. We're going to move forward. We're going to add again. We're going to add our 1. That means our sum is now 3, not greater than or equal to 7. Our sum would not be 5, or we're going to add 5. Our sum is now 8. That is greater than or equal to 7. What we're going to do is we're going to now say, okay, now that we're greater than or equal to 7, we need to subtract our start. We need to shrink our window. So we're going to say our start num is our start num variable gets our array at start, which is basically going to be 2. We're going to take our sum and we're going to subtract our start num, or beginning number, from that, and then we're going to update our start to point to our new as our new start. And the end of this loop, we'll have to update our min, which our min is going to be what? Our min length will need to be updated using a min function, the min in between our min length currently, and then the length of our, length of our window, which is equal to what? Our start, it'll be our end plus 1. It's our end minus start plus 1, usually. That's our window. So I'll say end minus start plus 1. And that works because our start is now 1, after we've already gone through our loop one time, our catch statement. We have 1, our end is pointing to, currently our end is pointing to 5, which is index 2, plus 1. So it'll be, what'll it be? What is it? So that's 2 minus 1 plus 1. That doesn't make any sense, right? That doesn't make any sense. Well, our length is, we want 3, right? Our expected result is, oh no, it's 2. What? Why? Oh, because there's a lower. Haha. Got you. Okay, so we're gonna compare infinity to, which is lower, infinity or that length is still wrong though. If our end is currently pointing to index 2, right? We just got to 5, and that gave us our loop. Gave us 8. We increment our start. That's now basically 2. That's not making sense. That's wrong. Why is that wrong? I'm looking up the solution. I'm so bad about this, but no, that's right. Oh, but we do it before. Okay, what the fuck? I gotta figure out when it makes sense to do this. Why did? I I'm a little confused by that. So it seems like when we're tracking a count of something from the array, we should be doing our calculations after. That's the current math that I have. So what the solution just showed that we're gonna do our min calculation beforehand, and that was the obvious solution. But from our last problem, I thought that we had to do our sum calculation after the fact. Well, actually, that's not after this. Is the first one we're seeing this. Okay, there are problems coming after this where we have to do our calculation after the loop is run. So I got to take note of why that is, because that's a weird setup. But okay. So our min length gets min of our current min length, and then the end minus start plus 1. Okay, and that's pretty much while sum is greater than or equal to s. That's basically it. Okay, so if we run our example through the code, we should be able to, at least verbally and on a whiteboard, come up with a solution that makes sense. If it doesn't make sense on English and on the board, it won't make sense in the code. Let's just keep it a buck. All right, return min length. Cool. Let's run through it. So we start back at 0. Start back at 0. Okay, so we have start is at 0. We're gonna add to our current sum 2. The current sum at 2 is not greater than or equal to 7. We move on. We add 1, that's 3, not greater than or equal to 7. We add 5, that's 8, which is greater than or equal to 7. We're gonna store our min length now, which will be end is at 2, start is at 0. So it's gonna be basically 2 plus 1, which is 3. So our min length gets set up to be 3. That's a number that basically says that we have a subarray of length 3 whose sum is greater than or equal to s. Okay, that's our smallest one so far. We're gonna subtract our start from the sum. We're gonna subtract 2 from the start. Our sum now drops back to 6, and then we're gonna move our pointer. Our sum is 6 now, which is not greater than or equal to 7. We're gonna continue to add. We're gonna jump back out the loop. We're gonna add 2 to that, so that's now 8 again. Same thing as last time. So basically 3 is not 3 and 3, minimum 3. Cool. Our start now points to index 2, which is going to be 5. Our sum is subtracted to 1, so that's 7. We now add. That's crazy. No. What? No, it's 5. Yeah. I'm stupid. Where am I? Because that was 7, right? The 5 and the 2. Or am I crazy? What just happened here? Did we subtract it? We're at 2 now, so we're at index 5. That's our start because we just did that, and we subtracted a 1, so we're at 5 basically. So we're at 5. We're added 2. That's 7. That's greater than or equal to. We're gonna subtract a 5. Oh, okay, cool. So yeah, so the length of that, so our end points to 2, our start points to 5. Our window then is going to be 4, right? That's our end. 4 minus our start points to 2 plus 1. So 4 minus 2 is 2 plus 1 is 3. That's wrong. Because our start at this point really points to 3. So the calculation has to match up. So it has to point to 3. There's no way. Since 4 minus 3, which is 1, plus 1 is 2. So our length is now 2, is now smaller than 3. Okay, cool. We're pointing to index. I probably need to go over this again because I just messed that up. Start from 0, infinity. Cool. So we add 2 to the sum. I'm going to track our current sum actually, because I've not been doing that. So our current sum is 2. Start is 0. Not greater than 7. We add 1, that's now 3, not greater than 7. We add 5, that's 8, greater than 7. We're going to update our min, that now points to 3. What our calculation is correct. I can go through it each time, but I think it's correct, so I'm going to just leave it there. But if I want to prove it this one time, I would say, okay, our end is pointing to 5, which is, our end points to this. I'm going to mark our end. Our end points to the 2 index. So 2 minus our start, which is still 0. So 2 minus 0 is 0. Plus 1 is 3. So our min is now, the calculation is now 3. It's now infinity versus 3. And 3 wins, so our infinite gets updated to 3. So I'll put our min in here. I'll do it right every time. Okay, cool. But we subtract. So after we do that, we subtract then the start, which is 2. So then we have 6. And we upgrade. So then 6 is not greater than or equal to 7. So we move out, we add something. Our end is now pointing to the 3 index, the 2. We add the 2, that's 8. That's now, our min is 3. Our current min length is 3. Our current length is, we're comparing 3 to 3. Our start is 1. So we have, I have a bunch of stuff on my fingers. I hate that. Let me eat some apple for fuel. Okay, yeah, so our window currently is 1, 5, and 2, which is 8, okay? And therefore, we enter our loop, we compare our end minus start plus 1. So our end points to index 4, minus the start of 1, which is 3. That does not make any sense. If it's 1, 5, and 2, our end is pointing to the 3 index. Haha. Pointing to the 3 index. I probably should do this up here. Hold on. 0, 1, 2, 3, 4, 5. I just wrote the indexes on top of the list on the board because it's just smaller. So it's smarter that way. So we have 3 minus 1 is 2 plus 1 is 3. So we're comparing 3 to 3. We stay at 3. Cool. Then we subtract 1. So now we have 7. Sorry, that points to 2. Technically, our sum is equal to 7 now. Not greater, but equal. So we're going to enter our loop again. We now have... We're still looking at the 3 end. We didn't move out the loop yet. So the 3 end is still valid. So we have 3 minus 2 is 1. Plus 1 is 2. Now we're comparing 2 to our current, which means that we update this to 2 because 2 is less than 3. Min function of 2 and 3 is equal to 2. We move our start, actually subtract 5. We subtract 5, which is now 2. Update our start, which is 3. Now 2 is, we have fall outside the loop because 2 is not greater than or equal to 7. We add 3 and move our end. Right? Add 3 to what? 2. That's 5. 5 is not greater than 7. So we move forward. We add our 2, which is now 7. Length of that is 3. That won't update anything. Problem solved. Return 3. Or return 2. Okay? That's the walkthrough. I don't know why I ate that. That tastes gross. It's not smart to eat that. Don't eat. That was bad to get on camera. But we out here doing it. Okay. So our whiteboard solution works. So now we get to code it up. And it works. One thing I didn't do and haven't been doing is coming up with good test cases. because I know there's a solution, and I kind of know what the format is, so it's kind of bad because this method is kind of it's the minus the trade-off with this method of study is that you know what the pattern is already, so you're looking for something similar. When you're in an interview, you don't always know what you're going to see. So I need more test cases to validate my code. But running through your code can take a minute. So what you want to do is get through a test case quickly, right? But we're going to start coding this up now. We're going to keep track of it, but so we're going to use infinity here. We're going to say we're going to also keep track of our current sum, which starts at, I'll just say 0 for fun's sake. So for I in range, length of passed in array, we're going to say current sum plus equals array at I. We're going to say if, or say while current sum greater than or equal to s. We're going to take our min length, or the min function of our min length against the our what index, our I index. So this is really actually say end. So we're going to say end minus start plus 1. And we're going to say current sum minus equals array start. That's what we're going to subtract. Move our start up by 1. And that's the entire function, I believe. I grabbed the number in a variable first before I did that, but we're going to also return the proper number. I need to get better at testing. I feel like I don't have enough test. Okay, let's do one more test. And you can label these tests, by the way. You can run IDs. But I don't know. I'm not testing for a particular case, so it's kind of hard to be like, I'm gonna run an ID. This should be 8, 3, 4, 1, 1, 6, and we want to get 3 as an output. Does that work properly? That does work. Cool. So before I move on, and congratulations, clap it up, clap it up, clap it up. Before I move on, I want to label these tests and have more. I want to have a more, how do I call it? I want to be specific about what I'm testing, like the test case, like what's the test case, right? And you can have many versions that work, but you want to have like maybe 2 or 3 happy tests. But the reality is you want a test that's supposed to fail, right? I should know that, we expect this to return 0, right? Or we expect this to return infinity, right? So if I pass in, let's say for example, I pass in, our S is 8, our array is empty. I want this to return infinity. This should return infinity. And so if it doesn't return infinity, there's a problem, right? Oh, look, it does return infinity. So it's good to test that out and figure out for yourself, like what should run, what should not run. Yeah, very small function, easy problem. Easy to mess up too. So the next one we're actually gonna come up with more test cases that actually cover deliberate things. Like for example, at work, I come up with test cases and I actually label them. I just say, okay, this is testing this in particular, that kind of thing. That's important to do. Whiteboard cleaned out. Cool. Let's push this to Git. Let's clean the output. Other new hash. Anyway, update this. I'll push the name of the commit or the name of the problem as the commit. Cool. Next problem. I'm gonna do better this time. That was it. I've been on this for 40 minutes. That was an easy problem. That took a bit too long, but this is a medium problem. Okay. This is a medium. I'm gonna say a problem statement is in bold. And we're going to save that. We're going to write, I have an explanation for this already. I'm gonna bring this in. Do I usually use a 3? Use a 2, okay. I always spell that wrong. I use a 2? Why do I use this? A 2, okay. Weird. So my latest explanation of this problem was this. I have solved this problem before. I'm solving these again because I need to keep practicing. So eventually I do want to see, and with things like LeetCode and HackerRank, they have their own testing framework. I personally would like to branch away from this and apply some of these to like LeetCode problems. What's funny is that with LeetCode, I think there's more variety. So I might not be able to apply these specific patterns, but I do want to attempt to do them and see like how they fare over there. Okay, let's take a look. Let's get straight to it. So my current explanation is to have a start pointer, as usual, a max length holder, and a frequency dictionary. The problem is longest substring with maximum k distinct characters. I like to rename this sometimes to unique characters. So we're basically looking for the longest substring of a given string that has at most k unique characters. So for example, we're looking for the longest substring here that has at most two different characters. Any count, we want the longest string, we can only have 2 unique characters. So for example, the output is 4. Why? Because if we look through this list without doing too much math, the longest subarray is 4 characters long, and it's 4 characters long, but only has 2 unique characters in it, which is A and R, okay? That's the idea behind the algorithm. So I'd want to run like, it's a passing test because we expect this to return this positive value, right? I expect this to return what value? That's important. It's important to label these and make sure we have an understanding of what's going on. That's good practice to have. Right? So, same as last time, create a function. Taking our string, taking our k, return a code block, right? Add a string, add tests, go up 1, add tests, test this, pass in the string, the k, and the expected, which will be an int. K is an int, and this is a string. The goal will be to assert for each one that the longest passed in with s and k is equal to our expected. And we add below this a I by test.run call. Okay. Our testing framework's problem is now set up. We can run tests, do our thing. I like this pattern of just creating a test and like running it versus like, I don't know, let's run it again now. With this one, it's hard to create. You can't like edit the test, so it's kind of dumb that way. But I can't change testing, but I can go down here and like look at the main function. Oh, ha! I think outside the box though. So yeah, I can create my own main function. I can just run this code. This editor expects to see this problem. Hidden somewhere in this editor is a main thing, right? So that's kind of cool. Little JavaScript, little. Why is it in a variable? Why don't they call it a? It's weird. This is C++. They have Java here. I miss Java actually. I shouldn't lie about that. All right, let's run one of our tests. So, a successful test looks like this. We have our S string, K, and the expected output. That means we're gonna have our yeah, this is fine. ARAACI with LK being 2 and 4. Okay, that's the example of this, right? So we run there's an IDs array. It's iterable. We can label our tests and just be like, okay, here's tests, and then here's like we'll call it passing test. What we want the failing test to fail. So for example, so the point is to run through it out loud first, according to our framework for this. So if I look at the README, the point is to, and my VS Code is slow as hell. OBS recording makes this kind of slow. I need more resources, I think. Like slightly more resources. I'm also losing frames. The point is to, I don't have it here. Where did I put it? Did I put it in here? I thought I did. Oh, I didn't do a runtime complexity. Oops. Time complexity. This is worst case scenario, we eat the entire if it took the entire array, then we'd only have to subtract 1. If it took so the worst case would be in an increasing array, you'd have to subtract. I don't know. But at worst case, it's worst case you have to subtract everything before the end, which could be n minus 1. If I think about it, I'm not exactly sure. say 3 is the 2. I didn't know that. So I don't. I mean, so we have the n length loop. The while loop on the inside, at worst case, can run, I think, n minus 1. Because, for example, you have an array, let's say your S is like 10 or something. Well, I mean, it also consists like 100. Right, let's say you have a 1 and a 1 and a 1 and a 1 and a 1. 95. You're not going to hit 100 until your end is pointing here. Your start points here. Your end points here. Your while loop on the inside runs 1, 2, 3, 4, 5, which the length of this array is 6. So it really runs n minus 1. At worst, you're running n minus 1. So if it's n minus 1, is that n times n minus 1? No, that's n plus n minus 1, which is, I guess, n plus n. But that doesn't sound right. They do analysis of this? Okay, so it is. So I did get down to n plus n, which is good. Oh, look at me, so freaking smart. But it says which is asymptotically equivalent to n, which is just big O n. Space-wise, oh, this is the wrong fucking one. Wrong freaking problem. Last problem. But I think it's still n plus n though. Yeah, okay. Okay, this is officially big O n because in the worst case, we can run the inner loop processes each element only once. Really? Well, at most once. So it's n. Oh, I got to the same conclusion, but for different reasons. I thought that in the worst case, let's say, for example, your S is 100. Try to find the smallest subarray that gets. The smallest subarray is the whole length. Oh, yeah, so this makes sense. Oh, sorry, yeah, the problem itself. Okay. Oh. Yeah, so, okay. Yeah. That's crazy. Yeah, because the inner loop, because the outer loop runs n time while the inner loop runs n time at most, which is big O n plus n, which is so space complexity. The space is, this is k. No, last problem. This is 1. Since we're not storing anything extra. Excellent. Okay, that's cool. I like that. Back to this solution. Okay, so to make this test pass, what was I gonna do? Yeah, so I was going over the. I feel like I had them in here at some point, but I don't anymore. I don't know what that is. Oh, I added them here like an idiot. I want to add one above this. Add a Never forget. I'm gonna paste this in there. I'm gonna add a I'm going to add this, add this. I'm going to, well, actually, let's do this. It's not Python, this is Markdown. Okay. Complexity. I'll keep it open. Cool. Let's take a look. All right. So our passing test should return a 4, which it does. Oh shit, wait, what? Isn't this IDs for the test? I'm confused. Okay, so our test is passing. If I do a 3, how does that impact the test? Let's see. And it runs the entire test suite, which is fine, but this is nothing, by the way. Oh, so it does do something. It's not the bad. It doesn't really matter that much. I don't care about it that much. Now that I see it doesn't really do much. Yeah, it puts the input out as a string, as an array. I mean, that's whatever, but okay. Anyway, so we have one passing test. I want another passing test with a different output. So I wouldn't have examples. I'd have to come up with my own examples. So for example, I need to come up with another one. I'd say like but you can only have so many distinct characters, right? So if I do the same one, A, R, A, H, C, I, and I said like K is 1, our output should be 2, right? Run this, it failed, right? Why did it fail? Why did it fail? Well, we said the output should be 2, but it was actually 4. So what happened there? Oh, look, our function returns 4. Not very smart. So that forces us now to come up with some kind of solution. Cool. You could even add more tests. Okay, yeah, sure. And you could even add more tests to even get more what's it called, specific about that. Anyway, it's 11:06, 11:07. Oh, my kitchen clock is off. I'm still eating an apple though, right? Weirdo. Okay. So, sliding window, generally similar pattern across the board. So the point is, and we have our solution pretty much written out already. I'm just like rehashing it with the right practices, right? So we have our starting tracker 0. We have our I'll say max length, which is starting at 0. We have our frequency array with this is an empty dictionary. Cool. We're gonna loop over the string. I like to use range. I only like to use for each loops unless I'm doing something with the item. If I'm not doing something with the item, I just want to take a look at it. We'll just use. I mean, for each, and they're interchangeable. Sometimes it makes sometimes you can always use it for each. You can always use the length, the range calculator. You can always use range. The only reason why you wouldn't use it for each is if you're modifying the object. If you're adjusting the list as you're iterating, it will end on its own with a range, and a for each it does not do so. But in Python they're kind of all for each loops. So for example, I got that on camera. I'm gross. It's S, but whatever. We're tracking distinct characters using a dictionary. So when we look through the list, this character list, this string, we're going to keep track of the count of each character. We have to keep track of the count. So we're going to do some dictionary updating. So it's like if char, not in frequency dictionary, add it, and then frequency at and increment it. So we're always going to increment. We're going to add if we don't see it already. Our catch is if we hit. Okay, now I'm going to compare this to the last one and see. I'm going to see why the max or min update changes. I'm not exactly sure why it changes. But I want to figure that out, okay? So in this case, we're going to say while the length of frequency, right? While our total character, or our distinct character count is, greater than K. So once we have more than that, then we want to, gather our start character is what? It's really S at start. And then we're going to go into frequency at the start character, and we're going to subtract 1 from it. And then we're going to do a check to say if frequency at start character equal 0, delete that. And then we're going to do a max length update based on our. I need to also update our start variable. Well, the start should really only update if we delete it though. Right? Am I crazy for that? I think the start should only update if we delete it, but ideally you couldn't look that up. You'd have to look. But apparently every single time oh yeah. So why do I keep thinking the start updates if we delete it? Yeah, I need to get that. For some reason, I keep thinking that we're gonna subtract the C or in this case the A. If there's like 3 A's, we're gonna subtract. It's not the first A. It'd be the index 2 and 3. It'd be the second and third A. But you want to subtract them in the order they showed up. So ideally, you delete it and then start plus plus. This is not Java, but you get the idea. Then we update our min length. This is the wrong problem. It's the wrong problem. I erased it, right? I didn't erase it. Okay, cool. But we don't want to update the start in the if statement. We want to update it outside of it, and then we do a max length check at the end of the while loop. So we do max length equal to max of max length against end minus start plus 1 as an offset. Then we just return our max length. Cool. This solution, I've been trying to test it. It works. My question is, for example, if we have our check, this check happens outside the loop. This check for the max length happens outside the loop. I'm not sure why that is. And I might need more examples. Actually, I think I do need more examples. I can't figure out. I want to think more about why in the previous problem, our min length was calculated in the while loop, and before we did any incrementing or any decrementing or anything else with the data, why did we take our min length here? That's what kind of bothers me, because in this case, on the whiteboard I have here, we're adding to this frequency. Wouldn't we want to, once we hit K? And I tried to come up with a solution that did that, but for some reason I couldn't make it work. But I do think there's a cause for it. But I'm not sure that it makes sense. So let's say, for example, in the opposite case, right? We took our min and we did it outside the loop. We would have to decrement before we ever calculated our min, and our min would be off. So just by virtue of doing it the other way, we find out that we have to do it the original way. Okay. Here, I couldn't solve it. So, it didn't work, right? But if I were to, so what would I say? Well, you have to run through your examples. That's the only way you could figure out whether or not that's going to work. So without it, you're kind of in your own world here. So I'll run through it in a second. I want to add one more test case, one that makes more sense, one that makes not more sense, but one that is a little bit testy. What if we get an empty string, and we say our k distinct character is 1? If our string never runs, our max length, technically we're going to decide is 0. If we get, let's say, for example, we have, a string full of characters. Let me type whatever you want. We tell it we want no distinct characters, and we should return, again, 0. I'm defining test cases just to define them as they run. Let's say that we want a string. So what are the constraints, right? Because can I just put anything I want here? Why am I getting code suggestions? This is a string. At that point, you'd run the loop and then exit and return, nothing, right? Same here. You'd want one distinct character, but you never get it, so you return 0. That's fine. What else can it be? Let's see. I don't know what else. Why is it doubling up? I don't know. I think it's using like the Jupyter Notebook plus like Python somewhere else. I can overthink it. I already ate an apple. Half an apple. Kind of insane. I have an invasive thought to check my phone, but I want to finish this first. Okay. So, what's that put? It's the entire, okay, so for example, we have that already. Where the entire array is, well, we have an empty array, but let's do a couple characters. I gotta try to do. As long as this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. Excellent. All right, let's get a solution up. Start 0, max length 0, frequency empty dictionary. So for and in range length of s, we're going to if let's say I put new char last time, so new char gets s at index end. If new, I can type there, new char not in our frequency dictionary, we're going to add it. So frequency at new character gets 0. We're always going to increment at our new character, assuming it exists. Sweet. And our statement, our catch here, our conditions are that the length of the frequency is greater than k. And in messing with it, I figured out that this is the best way to do it. The other ways just don't work. I don't understand. I don't always get why they don't work, but I had a hard time making the code like function. So we'll get our start character, because I wrote all this down on the whiteboard and tested it out, so it all works. Our start character gets s at start index. We're going to find frequency at our start character. We're going to subtract 1 from it. And if frequency at the starting character equals 0, we're going to delete it from the dictionary. We're always going to increment the start. This is not Java or JavaScript. After our loop, we're going to update our max length to be the max function between our current max length and the end minus the start plus 1. And we're going to return max length here. That's our function. Hopefully I didn't mistype anything on that, on the tests. They all pass. Excellent. Well, it's a trash function in the micro record. Apply their own to it. Well, it's just none of these things are just like. So I was studying. Man, I haven't been home in weeks. All right, cool. We're done for now. I'm gonna push the next problem to the repo. I'm gonna clear my output first. So tired, but we showed up. High five.